Okay, hello everybody. Welcome to physics. Today in this lesson we're going to cover what I consider to be the first lesson that is actual physics. We've done a little bit of math, we've done a little bit of science, but we're actually going to look at the physical world. We'll see our first equation today. We'll have 3 examples, and the math is pretty easy. Here we go. So we're talking speed and distance. Speed basically is how fast, distance is basically how far, but we're going to get a little more descriptive in our definitions. For distance, here's what we have. Distance is the amount of ground covered by an object. The amount of ground covered by an object. Now most of our phones measure this. They take the amount of steps you've taken, they can figure out how far you're stepping, and they can figure out how many miles you walked in a day. Distance is also measured by our cars. I believe it's called the odometer. If you say this car has 100,000 miles on it, that means that that car has traveled a total distance of 100,000 miles. Let's look at a visual example. Maybe you're walking around the block. Let's say you go 200 meters north. You go 200 meters east. You go 200 meters south. And to return back home, you go 200 meters west. So although you've ended up in the same place as you started, you have traveled 800 meters. You've gone a total distance of 800 meters. So basically the distance, you just add up all the travel that you've taken from one time to another, like in one time frame. So in that case, that's distance. So not really any equations for distance. It's pretty easy to calculate based on like visually what's happening, or very often there will be some sort of word problem that describes the distance. But on to bigger and better things. Let's look at speed. Now speed will result in in defining speed, we'll come up with our first physics equation of the year, and I'm sure you've seen it before. So speed, generally, if someone's moving fast, if they are covering ground very quickly, they have a high speed. This is also measured in cars. It's that needle that moves constantly as you speed up or slow down. Here's our physics definition for it. This is the rate at which ground is covered. Notice the similar wording in distance and speed. Distance is the amount of ground you cover, and speed is the rate at which you cover that ground. So basically these are two sides of the same coin. The only difference with speed is that it involves time, which leads us to our equation that many of you have seen before, I'm sure. Speed, S, equals distance over time. Now this equation would be useful for your whole life. If your GPS isn't working, you could figure out how much time it'll take you to cover a certain distance in your car while traveling at a certain speed on the highway. Google Maps uses this equation to figure out how soon you'll get to a location. It figures out how far you need to go, and I think they're using an estimate of how fast you might be going. Anyway, what do these letters mean? S is technically average speed, but we're just going to call it speed for now just because. There are many different types of speed that you can talk about, but generally we're just going to consider this speed for now. We'll go into that later. D, like I said, is distance. And T, of course, is time. Notice these units that I have in here. Speed can be measured in many things: miles per hour, kilometers per hour, but we're going to use meters per second. So if you see something, if you see a speed measured in miles per hour, that's an indication that you need to convert it. You need to do a unit conversion and turn it into meters per second. So although miles per hour is an actual unit for speed, we're not going to use that. We're going to use meters per second. Same goes for distance. If you see something in feet or miles or centimeters, we're going to want to convert those to meters, unless specified otherwise. The problem might ask you, it'll tell you, sometimes problems will tell you, keep it in centimeters or keep it in miles or whatever. But generally speaking, no, we want to revert back to meters. And finally, time. This can be in hours, minutes, years, but no matter what unit they give you, you don't want to use this equation until you have this in seconds. So our standard units are meters, seconds, well, meters, seconds, and any combination of those two. So meters per second is a combination of these two. Let's try some calculations. I've got 3 calculations here. If you're in my class and you're watching this from my class, you will be doing a quiz after this. And the nice thing about the quiz is that the quiz involves these same exact questions, but with different numbers. So here's our first scenario. Calculate the average speed. Calculate the average speed of a drag racer if it finished a quarter-mile race in 11.5 seconds. Alright, I'll repeat that in case you're having trouble seeing. Calculate the average speed of a drag racer if it finished a quarter-mile race in 11.5 seconds. So what we have here, we call this the given. This is all the information that's provided for us, and we're going to use it to find an unknown value. And I can already kind of see the unknown value. Hopefully you can see, what are we trying to calculate? We're trying to calculate S. Now once again, don't worry about the word average speed and average speed. They mean the same thing at this point in the course. So it's important to kind of label your problem when you're trying to solve it. I like to annotate, so S equals question mark. That means speed is what I'm trying to calculate. What else do we know? The numbers pop out at you. 11.5 seconds. Without reading anything else, I know that that's time. 11.5 seconds. I know that's time because seconds is a unit of time. Finally, right here we have quarter mile. That's a little less clear, but that is our distance. So D is 0.25 mi. Let's go look at the equation. Now you will have to memorize what units are proper, but at this point we're still taking notes. We can look back. Notice distance is supposed to be measured in meters, not miles. So we'll have to do a quick unit conversion. On today's quiz, you will not have to do unit conversions. On today's quiz, I provided all the questions, all the numbers with proper units. So let's convert this to meters. We do that by first writing the number that's given over 1. I'm going to write the necessary conversion factors. I forgot to put those in the problem. These here on the right hand side that I'm writing, you do not have to memorize these in my class. I will always provide these. Let me put them a little out of order. Yeah, you don't have to memorize these, but you will have to remember what units you're supposed to use. So if I give you something in miles, you need to know that's got to go to meters. So let's use these two conversion factors to change this to meters. I've got 1 mile on bottom. I've got 5,280 feet on top. We'll go a little farther. I've got 3.281 feet on bottom, 1 meter on top. Let's see if everything cancels. Miles cancels miles. I have a feet on top, feet on bottom. So those feet cancel, and it looks like there I have it. Now if that was a little fast, if that conversion was a little fast for you to follow, that's okay. The main thing that I want you to see here is that distance is not supposed to be in miles. When we do calculations with distance, it's got to be in meters, as the equation up here says. So 0.25 times 5,280 divided by 3.281. If you've got a calculator handy, it will be useful to practice. So there's our distance. Our distance is 403 meters. Our time is 11.5 seconds. We're trying to calculate speed. So finally, we can actually use the equation. The point of the day. We can actually use the equation we're supposed to. Speed equals distance over time. All right. It's good to write down the equation, and as you plug in numbers, rewrite the whole equation underneath. S equals 403 over 11.5. And I'll have my answer. I have here written 35 meters per second, but let's make sure. Yep, 35.0. 35.0 meters per second. So that same question is on the quiz, but with different numbers, and on the quiz, you won't have to do this unit conversion. On to the next two. For this next problem, we'll look at a cheetah. So a cheetah, a healthy cheetah can go more than 50 miles per hour. They've been clocked at 70 miles per hour. But I went with the lower value just to be conservative on the numbers, because they'll still be impressive. Here's another calculation with our speed equation. Calculate the average speed of a, oh snap, oh no, that's the last problem. No, my bad. We'll rewrite it. We want to know how far a cheetah would go. Sorry about that. Here's the actual problem. How far would a cheetah go? In 2.2 seconds if traveling at a speed 55 miles per hour. Okay, so let's break it down. What's the unknown? What are we trying to find? The question asks, how far? If I'm asking how far it goes, that's gotta be distance. That means they're asking me for distance. How much distance does the cheetah cover? If I say how fast, maybe they're talking about speed. If I say how long does it take to get here, that might be time. But let's read on just to make sure that's distance. Take a look at this number here, 2.2 seconds. Well, since it's seconds, it's got to be time. And this obviously has got to be speed. It's in miles per hour, so that's speed. So our answer is going to be in meters because it's distance. Time is seconds, but this is a problem. What's the real unit for speed? Well, I don't have my other, I can't flip back to my page so quickly, but let's look here. This is the notes. This is pretty similar to what you wrote down before. Speed has to be in meters per second before I use the equation, so we've got to convert this. Once again, you don't need to memorize conversion factors. I will always provide these conversion factors for you. 1 hour is 3,600 seconds. I might make a big paper with all of them on it. Anyway, here we go. We got to write down the unit that we're converting before we do our equation. Whoa. 55 miles divided by 1 hour. It's going to be a conversion we've done before. I'm going to use this first one. I put 1 mile on bottom and 5,280 feet on top. And that'll cancel out my miles. If I stop here, my value would be in feet per hour, but I want it in meters per second, so the feet's got to go as well. Hence the second conversion factor. I'll put 3.281 feet on bottom and 1 meter on top. And finally, I've got to get rid of hours, so I'll put 1 hour on top, 3,600 seconds on bottom. So if you type this in the calculator, you'll get about 24.6. Again, if that conversion was a little uncomfortable, don't stress about it. For the quiz today, I will provide the number in meters per second. So, hey, if you're totally lost, let's ignore that for a second. Let's get to the main point of the lesson. The main point of the lesson is to use this right here. Speed equals distance over time. And if we look back up here, everything we need to know is present. D is the thing we're trying to calculate. T is 2.2 and speed is 24.6. So 24.6 equals D over, so in here, 24.6 equals D over 2.2. And this situation is a little more complicated than the last problem. We have to get D by itself, so we'll cross multiply. So it's D times 1, 24.6 times 2.2. Well, d times 1 is just d, and 24.6 times 2.2 is 54.1. And there it is. That's our answer. We have got one more here. I might be skipping the conversion percent. Let's see. No, this is an easy conversion here. Okay. Let's focus the camera in a moment here. All right. Last one. How long would it take a .22 caliber bullet to go 12.2 meters if moving at a speed of 300 meters per second. It's about 1,000 feet per second. How long would it take a .22 caliber bullet to go 12.2 meters if moving at a speed of 300 meters per second? Okay, let's figure out the unknown. Are they asking us to calculate speed? Are they asking us to calculate time? Or are they asking us to calculate distance? And here's our kind of action question. How long would it take? To me, I'm kind of hungry right now, so this makes me think about pizza. How long would it take the pizza to get here? You want to know when it's going to be here, because you want to eat now. So time, T, is what we're trying to calculate. Moving on a little further, the numbers kind of jump out at people when they're looking at these problems, but you got to be careful. .22 caliber. Does that have anything to do with what we looked at today? And the answer is no. .22 caliber is not in our equation of speed. Speed, none of these letters means caliber. This is speed, this is distance, this is time. So 22 is actually not useful to us. This tells us the size of the bullet. Maybe it's the weight. I don't actually know what caliber stands for or what it means. Let me know if you do, because I don't know. Anyway, moving on. It goes 12.2 meters. Since that's meters, it's got to be distance. And it's moving at a speed of 300 meters per second. So there's everything. We're looking for time, we're given distance, and we're given speed. How about our units? Well, this is in meters, so we're good. This is in meters per second, so we're good. So looks like no conversions on this problem. So it'll be quite easy. Write down the equation you're going to use every time you're solving a problem. Write down the equation with no numbers, then write down the equation with numbers on the line below. Don't work sideways. Don't work to the right as you plug stuff in. 300. Okay, D is, well, we're not plugging anything in for D, so we just leave D. And T, we're going to plug in, oh, I messed that up. This is why you should use pencil, but I got to use pen so you can see. It's 12.2 actually. Distance is 12.2. and t is time is what we're trying to calculate. From here, we got to get t by itself, so we will cross multiply. To cross multiply, I like to put a 1 underneath there, and then you multiply diagonally. It's 1 times 12.2 and 300 times t. So that's 12.2 equals 300t. Now we divide both sides by 300. And we got it. So that's 0.0407. Don't forget your units in your answer. Now this is a very small number, but that makes sense. Bullets travel very, very fast, so it takes them very little time. It takes them very little time to move a distance like this. This is about 40 feet. So remember, on today's quiz, they'll all be kind of like this, where you just jump straight to the equation. Don't worry about unit conversions on the quiz today. Like this unit conversion, you won't have to mess around with that on the quiz. Like I said, you're just jumping straight to the equation. It's the same as these 3 examples, just with different numbers and unit conversions. Let me know if you have any questions, and I will talk to you all soon.